This will be the first tutorial for Horton infiltration model. This question was obtained from Heriot University, UK, Dubai, Malaysia. So let's go to it. First of all, the question is a catchment soil is found to have the following Horton infiltration parameters. F naught 100 mm. First, let us know what each of the symbols signify. F naught is the initial infiltration. FC is the final constant infiltration rate in millimeter per hour. K is empirical coefficient for a particular soil and surface, usually in minutes. Then we have T, which is your time. We have FP. FP it's initial capacity, initial infiltration capacity, maximum infiltration rate. P is the precipitation, and the I is intensity. So normally you'll be given this is the equation for the Horton model. Estimate the temporal distribution of the infiltration in millimeter during a storm whose hydrograph is given by the data in the table. Interval 0, these are all in minutes. Change in T should be in hour. So first you have to convert it to hour, and you know how to convert to hour. You divide by 60, you get 0.167 for each of them because the intervals are 10 minutes. You get your time, which is the intervals, and then you get your intensity. This is also given. This is what is calculated after the test has been carried out. In order to move on from this, first you have to get your change in PI. Now, how do you get your change in PI? You have to convert your intensity to precipitation, as P is precipitation. You have to convert your intensity to precipitation. And how to do that? 7 multiplied by 10. And that will give you equal to 1.67. Yes? And that will be your time. So you put it here. First, definitely, you know this should be 0. And then this will be 1.67. After that, the next one would be, if you multiply, we are multiplying this by this by this. This will be 3.33. 3.33. And then the next one will be FPI. You get it using the formula that is given. The formula is FP is equals to FC plus F naught minus FC exponential raised to power minus KT. Now we have our parameters. F naught is 100 mm per hour, FC is 20 mm per hour, and K is equal to 2 minutes. So the equation will be FP. Each value of the time, you have to put the value for each one. So the first one was 0, the second one is 10, the third is 20. So you come here, the first will bracket 0, and when you put that in your equation, you would get the value equal to 100, and that will be the value here. And when you want to do the next one, you use 10 here, here will be equal to 10, and then you do that, you obtain a result of 20, and then you put it here, 20, and then after that, the next one, you repeat the process over again in FI max with an average of this. You put 100 plus 20 divided by 2, the average of 120 multiplied by the change in T, which is 0.167. So this, you're going to start from here, and this will give you 3.33. The 10.00, this will give you 10.00, and the next will be 3.33, and the next is 33. The next would be to obtain your change in Fi max, Fi, and this is your change in Fi. This is gotten from change in Fi. You say this and this, which is minimum. This is minimum, 1.67. So you put here 1.67. And then the next one, which is minimum, they are the same. So 3.33. This, for your Xi, you're checking between change in Pi and change in Fi. So you're gonna say 1.67 minus 1.67. This will give you 0. 3.33 minus 3.33 is gonna give you 0. 13.33 minus 3.33 is gonna give you 10.0. And then 16.67 minus 3.33 is gonna give you 13.33. Sorry about that. The next is 13.33 minus 3.33. That will give you 10 as well. And the last is 1.67 minus 1.67. This will give you 0. So in order to report this, you would say the infiltration started at 10. So this is the value you're looking for. The infiltration started at 10. Thank you very much, and hope this was helpful. Have a lovely day.